Hi guys, in this video we're going to start by looking at understanding collision theory and then the factors affecting rates of reaction. Factor 1, temperature. Factor 2, concentration or pressure for gases. And factor 3, surface area. Before finishing off with a summary.
Let's start by introducing what is known as collision theory, which helps us understand the rate of chemical reactions. If you've watched our video on calculating reaction rates, you'll know that the reaction rate for a chemical reaction is a measure of the change in concentration of the products or reactants per unit time, and therefore an indication of how fast or slow a reaction happens. A good way of understanding and predicting reaction rates is using something that's known as collision theory. The basic idea is that we can understand rates of reactions by thinking about how reacting particles must collide together in order to form a product. In this diagram we have reactant 1, which is shown in blue, and reactant 2, which is shown in pink. These two reactants must come together in a collision if they are then going to go onwards and form the product, or products of this chemical reaction. As well as colliding, the particles also need to have enough energy in order for the reaction to happen. The two or more reactant particles must have an energy that is greater than the activation energy when they collide, or the reaction will not happen. Again, we introduced the definition of the activation in another video, so you might want to watch that one if you haven't seen it before. But here we can just remember that an activation energy is the minimum energy that is needed to start a reaction. And this is why the reactants need at least that much energy if the reaction is going to happen. We can kind of illustrate what we mean by looking at an example. Let's consider a reaction for which the activation energy is 14 kilojoules. The exact value of the activation energy for a reaction will depend on what is reacting and what is being formed, as it depends on the bonds that are broken and formed during the reaction. But we've just chosen 14 kilojoules here as an example. Remembering also that 1 kilojoule is equal to 1000 joules, and the energies are always measured in joules or kilojoules. So 14 kilojoules is the same as 14,000 joules. I've just noted that there so you can remember. The important point about the activation energy being 14 kilojoules is this is the energy that the particles need to have if they're going to react. Let's consider two separate situations which we can label as 1 and 2.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the SnapRevise smiley face. Join me today and together let's make chemistry at GCSE a walk in the park.